Titration is an analytical chemistry technique, which means we're going to take some very exact measurements in order to determine the concentration of a solution. It works by using a chemical that will change color depending on the pH. The substance we will use is called phenolphthalein, which will go from completely clear to a bright pink right around a pH of 8. In order to analyze these concentrations, we will need to know the exact volume of each substance that we use, and we will need to know the concentration of one of those substances. I'll go through the calculations at the end of this video. There are many chemicals that change in basic or acidic conditions, which can change their color. This is extremely useful because it allows us to determine the concentration of an acid or base just by looking at the color of a substance. Be careful during this lab. We will be using lye and hydrochloric acid, both of which are caustic. They will be in low concentrations, but they can still cause chemical burns if you aren't careful. If any spills on you, rinse it off quickly. For this lab, you'll need a ring stand, a burette, which is a tool for measuring precise volume changes. You'll need a funnel, a 250 milliliter volumetric flask. You'll need a glass funnel, a 250 milliliter Erlenmeyer flask, a 150 milliliter beaker, an automatic stirrer, a phenolphthalein dropper, and sodium hydroxide. The first thing we need to do is make a solution of sodium hydroxide with an exact concentration. This will be our known solution. Do this by measuring out 5 grams of sodium hydroxide and then dissolve it in about 100 milliliters of distilled water. You don't need to measure the water exactly at this point because we will bring it to exactly 250 milliliters in our next step. Stir the sodium hydroxide until it dissolves, then pour it into the 250 milliliter volumetric flask. Add water to the beaker that contained the sodium hydroxide to get as much out as possible. We're trying to be extremely exact here. Then add this to the volumetric flask as well. Slowly add water until you get close to the line on the flask. Then use a dropper to reach the line and be careful not to go over it. The bottom of the meniscus should be level with the line. If you go over the line, you'll have to start over. Cap the flask and invert it several times to get it to mix evenly. Make sure that you hold the cap securely so that the solution doesn't fall out. Then label the flask as NaOH with a 0.5 molar concentration. Measure exactly 20 milliliters of the hydrochloric acid. In this video, I'm using a 0.2 molar concentration, but in the lab, the concentration will be unknown. Pour the acid into the 250 milliliter Erlenmeyer flask with a stir bar and place it on the stirrer. Set up the burette on the ring stand so that the end of the burette is just above the mouth of the Erlenmeyer flask. Switch out the Erlenmeyer flask for the 150 milliliter beaker. Pour the sodium hydroxide into the burette using the glass funnel. Stop before the level gets to the 0 mark. Using a wash bottle, spray off the tip of the burette and let a little of the sodium hydroxide through to fill up the tip. Practice opening the stopcock to let just a little bit of the sodium hydroxide out at a time, as we will need to let it drip or let out a quick, short burst to be as accurate as possible in our measurements. Now, record the initial volume of the sodium hydroxide. For each trial, we will need to use the change in volume in our calculations. So it doesn't matter where on the burette the level starts as long as we record it. Place the Erlenmeyer flask back under the burette and start the stirring. Slowly open the stopcock and let the sodium hydroxide flow through. Only let out a little at a time to keep a close eye on the state of the reaction. The pink will appear as the sodium hydroxide raises the pH, but it will revert back to clear as the acid and the base react. When there is no more acid to neutralize the base, the pink color will stay. That's how we know that we have fully neutralized the solution. When the reaction has completed and the flask remains pink, record the final volume of the sodium hydroxide. Then do the math to determine the initial concentration of the acid. It's standard procedure to run a titration 3 times in order to get the most accurate result possible. So rinse out your Erlenmeyer flask at this stage, put in a fresh bit of acid, and restart your titration. When we're performing a titration, what we're really performing is an acid-base neutralization. And so we've got that right here in this reaction. We've got hydrochloric acid reacting with sodium hydroxide, and those are neutralizing each other. What we're trying to figure out is, what is the concentration of the hydrochloric acid? In order to figure that out, we need to get to a complete neutralization. So we're going to be adding sodium hydroxide until we have a perfectly neutral solution. And that's going to be when our solution changes color. So once we've done that, now we actually need to do some calculations in order to figure out what is the concentration of the HCl. We have a given concentration of sodium hydroxide. This is the solution that you made in the lab. This is a 0.5 molar solution. So when we do our calculations, we need that concentration. We need the volume of the sodium hydroxide, which that's what we're going to measure during the titration. And then we need the volume of the hydrochloric acid that was titrated. And that's just going to be what's in the Erlenmeyer flask. So if we look at these numbers, we can put a little table together. And one important thing here is that we always do 3 rounds of titration just to make sure our results are accurate. Because often on the first round, we overshoot our numbers. So we do 3 rounds and then we take the average for our results. So in each round, we're going to have a concentration for each substance and a volume for each substance. Now I can go ahead and put in here, because I'm going to be using the same amount of hydrochloric acid for each round, I'm going to put in that 20 milliliters. So that's the amount of acid that I put in the Erlenmeyer flask that I drip the sodium hydroxide into. And then I'm using the same sodium hydroxide each round, so it's the same solution, so it's all going to be a 0.5 molar concentration. So I can put that in too. So before the lab, you can have this already set up in your calculations. And then once you do the lab, all you need to do is measure this volume. And that's going to be that change in volume when you run your titration. So let's say your volume started at 0.6 milliliters. That's where mine started in the video. And then after you run one titration, let's say you end at 10.5 milliliters. Now what you would do here is you would take 10.5 minus 0.6, because that would be your change in volume. That would just be 10.5 minus 0.6, and that would give you 9.9 milliliters. Nice and simple. So we would put that in for our V2. For round 1, that would be our volume. We started at that volume and we ended at 10.5. And so our change in volume, the amount of volume that we actually put into that Erlenmeyer flask of the sodium hydroxide, was 9.9. And then we'd run our calculations. And our calculations are very simple, because what we're saying is, when the number of moles of these two substances, hydrochloric acid and sodium hydroxide, are the same, we will be perfectly neutral, and that's when our solution changes color. Well, our number of moles is just equal to the concentration times the volume, because our concentration is measured in moles per liter. So I can just put that here, moles per liter. And then our volume is measured in liters. So we're just multiplying moles per liter by liter. That leaves us with moles. So that's the calculation that we're doing here. We're just taking CV equals CV. And that's going to be true when we are fully neutral. So I'm going to do that below. So for round one, I have my acid concentration and volume equals my base concentration and volume. And for round one, my numbers are 20 milliliters. So I've got an unknown concentration, unknown C, times 20. And it's okay to use the milliliters here because they're going to be canceling out anyway. So it's going to be equal to, and then 0.5 times 9.9. And so to solve that, I'm just going to divide both sides by 20. So I take 0.5 times 9.9 divided by 20, and that should give me, and that'll give me a concentration equal to 0.2475. Let's round that to 0.25. So it's going to be 0.25 molar. Great. So then I would run a second round for this titration. So I would leave my setup the same way, and I would just pour out my neutralized solution, rinse out my Erlenmeyer flask, and then put in more hydrochloric acid, another 20 milliliters. I'm trying to be extremely exact on that 20 milliliters. I don't need to change out anything in my burette because I'm just going to go from 10.5 milliliters to the next measurement. So I'm going to run my titration again, and after that, let's say I stop at 20.1 milliliters. Well, now I'm just going to take the difference between these two measurements, and that's going to be the volume that I added this time. So that change in volume will just be 20.1 minus 10.5, which is equal to 9.6. There we go. 9.6 milliliters. So that's the number I'm going to put in for my second round. So V1 and C2, those stay the same, but 9.6 milliliters is the number for my second round. And that's common. You're usually going to see this go down because you're going to get more precise as you go on, because you're going to get closer to your target point, you're going to slow down. So we're just going to plug those numbers back in, and since everything was the same, the only thing I need to change here is this 9.9 to 9.6. So let's do that. So I've got my equation set up. Now I'm just going to divide both sides by 20. And now when I run that, I get 0.24. So 0.24 is my concentration for my second round. And then I want to run this one more time. That's going to be in molar. So I'm going to go back. I'm going to empty out my Erlenmeyer flask. And then I'm going to refill it with fresh hydrochloric acid. I need to make sure I rinse it out thoroughly. And then I'm going to run my burette again. And so this time, let's say it goes to 29.6. So 29.6, and now I take the difference between these two measurements. And that difference is going to be 9.5 milliliters. So now I bring that back over, and that's my round 3. And now I'm going to, or I'm sorry, that was 9.5. So now I'm going to take that and put that back in my calculations. Now that I have my equation set up, I just divide by 20 again. So these calculations are nice and straightforward. They're the same each time. And I'm going to end up with C equals, I'm going to end up with a 0.2375, and we're going to round that to 0.24. Awesome. So then we come back up here. We go 0.24 molar. Fantastic. And those will be my final numbers. So that's what you need to turn in with your discussion section, is your calculations and this table of your concentrations and volumes.